So welcome to How Positive Are You, Dr. Richards? It's great to have you with us today, and we look forward, along with our listeners, to learning something about HIV tests.
Well, thank you for inviting me to speak with you today.
Thanks for being on the show, Rodney. Let me start by asking you to describe your work at Amgen, when you started there, and what kinds of things you worked on.
Yes, I actually began working with Amgen approximately 12 months after groundbreaking. At that time, it was called Applied Molecular Genetics, and I was hired as a synthetic organic chemist to perfect the novel chemical reaction that was developed by Dr. Marvin Carruthers' labs at the University of Colorado in Boulder. And that reaction was for the purpose of creating DNA from scratch. In other words, small molecules, and we could create entire genes. Well, at least that was the goal, and we actually achieved that goal. When I began working at Amgen, our facility at that time was quite a shock to me. I'd actually driven up to what I thought was the right address, and there was a building that said Genes on the outside of it, and I presumed that was the place. And I walked in, it turned out to be Gene's Auto Garage, and they pointed me to another building, and I walked in that building, and it was actually just a garage with no running water other than the bathroom. We had a space heater in the ceiling for our heat, and the garage door served as our fume hood when we needed to get rid of stinky organic solvents.
Well, Amgen has certainly come a long way. What kind of business are they doing today, if you know in dollars, Rodney?
Oh, Amgen is about 14,000 employees today, and their annual earnings are right around $14 billion as well.
So that was a interesting beginning to what became, you could say, one of the greatest success stories in biotech.
Yeah, I certainly had no idea when I walked into that garage that the company would be that successful, clearly.
And just to go back to your own beginning, what was it that motivated you to get into that line of study and work? What was it that you hoped to accomplish with your studies and eventual work?
Well, organic chemistry was just something I was attracted to because I enjoyed the creative process, the ability to create something brand new from scratch. And when I heard that Dr. Carruthers had developed this technology to create DNA, I was just overwhelmed with the possibilities. What that meant was, among other things, we could take any published DNA sequence and create it in the laboratory, saving massive amounts of time trying to isolate it from humans.
Rodney, before you started at Amgen, you did a PhD. Can you describe your research for the PhD and whether it was published anywhere?
Yeah, my research during my PhD was as what we call synthetic organic chemist. And in this sense, organic does not mean healthy. It means creating molecules that are mostly composed of carbon, hydrogen, nitrogen, oxygen, and the vast majority of drugs on the market are created by chemists in organic chemistry labs. And specifically my project was to create an organic molecule that would shuttle products across cell membranes. In other words, if you could get a drug from the outside to the inside of the cell, it may increase its potency. As an interesting side effect to that research, I had created the world's first molecular Mobius strip. And for those that don't know what a Mobius strip is, if you take a piece of paper, a strip of paper, and put a half twist in it and stick the ends together, it's a structure that only has one surface, and if you cut it in half, it doesn't fall into two parts. It actually it creates one large circle.
It's a great party trick.
I'm sorry? Oh, you use that as a party trick?
Yeah, it's a great party trick, yes, especially with little kids. They think it's pretty neat.
I loved it, and I actually did cut my organic molecule in half using chemicals, and that was one of the ways we proved that it was indeed a Mobius strip, because it did create one larger circle. And that was a fortunate side effect to my research, because that was published in science news magazines around the world.
Now, in April of 1984, Dr. Robert Gallo announced to the world that he had discovered the probable cause of AIDS, a retrovirus that would later be named HIV. And this somehow found its way to you, Rodney. Could you explain your involvement from the very beginning of HIV diagnostics?
Sure. As I mentioned earlier, we were successful in creating DNA from scratch, and that led me into a different field called DNA diagnostics. It was just developing. And the ability to synthesize DNA that's complementary to the DNA of a germ, for example, allowed us to create very, very sensitive diagnostic products. And Abbott Laboratories, which is one of the world's largest diagnostic labs, had expressed an interest in Amgen's technologies, and we had formed a collaborative arrangement where Amgen would tailor their new high-tech into, hopefully, faster, more accurate diagnostic tests that Abbott could push to the market. And that began in 1984, just shortly after they had licensed the patent rights to Bob Gallo's novel reagents. So I was fortunate to be able to start that collaboration at a time when that first so-called HIV diagnostic test was being developed at Abbott Laboratories.
Now, you've come around to the point of view through your experience in and around the diagnostic testing world that HIV tests don't test for HIV itself, and they can't tell us if someone is actually infected with HIV through the detection of antibodies or genetic material. In this podcast, what we'd like to do is have you explain to us how the antibody tests work and don't work, and then we'll move on to the other kinds of diagnostics that are used around the whole HIV hypothesis. Could you start with just a brief explanation of how antibody tests are supposed to work?
Yeah, of course. First, maybe I'll just talk about what an antibody is. Antibodies are proteins that are synthesized by our body in response to infection with a germ. And basically, they're proteins that bind to the germ, and in so doing, they either interfere with the ability of that germ to bind to other cells, and thereby stopping the infection, or they mark that cells that are infected for digestion by other cells in the body. These antibodies they're a very precise fit to the germ, and that's why you can use them to create diagnostic products. An antibody test, be it for syphilis, hepatitis B, hepatitis C, HIV, whatever, you're looking for antibodies to a germ, a particular germ. And in general, I call this, if you do get a positive antibody test to a particular germ, that's indirect evidence, I should say, of current or past infection. But they cannot be used to diagnose infection, not with any disease.
Now, what is the distinction here? Because some people will confuse this, I've noticed, and say, oh, the FDA's never said that there is a test for testing for HIV, which is incorrect. The FDA has approved things called HIV tests. What do they do, and what are they approved for if it's not for the actual diagnosing of HIV infection?
Well, that's a very good question. And you're right. The FDA has approved, I think, some 36 diagnostic test kits for medical use that contain the term HIV in the title. But if you look closely, you'll see that it's either HIV antibodies or HIV, excuse me, HIV antigens or HIV viral load, but none of them declare that they can be used to diagnose infection with HIV. So when you hear HIV test, in reality, none of those products even claim to be able to diagnose HIV infection with any degree of stated accuracy.
But if you're finding HIV antibodies, doesn't that indicate you had at least an infection and perhaps have one now?
Well, what it indicates is that you have antibodies in your body that are binding to the test kit. There's a possibility of false positives, and this became apparent with trying to test syphilis with antibodies. They're called biological false positives. And it means that on follow-up testing with another technology called culture, many people who were thought to be positive for syphilis based on antibody tests were, of course, found to be actually negative. And so there's a possibility that you do not have the germ. Even if you throw out the possibility of false positives, no, these tests cannot tell you if the germ is present. It's kind of like, I use an example, if you see a paw print in the forest of a fox, that doesn't mean that the fox is still there. It would mean, indeed, that the fox was there.
Now, with HIV, there's been some question about the fox. Is there a fox? And you mentioned these reactions to what's in the test kits. What is in the test kits? Do we know that is HIV specific? Is there evidence of a fox?
Well, of course, it depends on who you talk to. But when Abbott Laboratories put out their first HIV antibody test, they were very clear to put in their package insert, and this is the literature that comes with the test that's required by the FDA, that there really is no recognized standard for determining the presence or absence of HIV antibodies in a sample. And that's still true today. So what they used for their what's known as a gold standard, which is what you hold up against your test results to see how well it performed. And they had no gold standard because there was no test, even elaborate test for HIV at that time. And, excuse me again. So what they used as their gold standard is people with clinical AIDS were presumed to be HIV positive, and healthy blood donors were presumed to be negative for HIV infection in the past or whatever, or currently. And so that's how they assessed the accuracy of their test kit.
So just to get this straight, on the thing called the HIV antibody test, there's a disclaiming sentence that says there's no recognized standard for determining the presence or absence of HIV antibody in human blood?
That's correct.
And we decided that certain samples were positive and contained HIV because blood was taken from original AIDS patients who tested positive, and from their positive tests it was assumed they had a virus, and negative people were assumed not to have a virus? Is that roughly? That's
very close. Actually, when this test was first coming out, even the Center for Disease Control emphasized, and I'll read you a quote here, a positive test for most individuals in populations at greater risk of acquiring AIDS will probably mean the individual has been infected at some time. Whether the person is currently affected or immune is not known based on serological tests, meaning based on the antibody test. So at that time, all mainstream researchers realized you could not use antibodies for diagnosing an infection.
But that changed in the era of AIDS at some point. Like, why did that change? Why did people suddenly assume that an antibody was proof of current infection?
Well, that was actually just announced. It was never proven. It was never demonstrated. It was never shown. And it's interesting. The CDC in 1987 just sort of unilaterally announced that the presence of antibody is equivalent to infection without citing any scientific study to establish this. And it's even more baffling because if you take antibody-positive persons and draw their blood and perform what's known as a culture, And I don't know if we'll elaborate on that later, but it means you actually grow the germ. Many antibody-positive people come up culture negative. So the culture says that they're not infected, and yet the antibody test, if you use this logic of the CDC, says that they are infected. So it's kind of a paradox.
And Rodney, is that not also true of antigen tests, that many people who are antibody positive are antigen negative, and yet an antigen test is supposedly looking directly for viral proteins, whereas an antibody test is just looking for your body's reaction to those proteins?
Yes, that is correct. That the majority of people that are considered positive for HIV based on antibody tests test negative on what's called the P24 antigen test. And again, maybe I should explain a little bit about what the antigen test is. And the antigen tests are, you'll see products in for antigen to numerous other germs as well. But in the case of an antigen test, what you're looking for is a protein building block of the germ. So if you've properly characterized your germ, properly isolated your germ, you can break it into its protein fragments, and you stick those proteins onto a solid surface, generally a piece of plastic, believe it or not. And then you take the blood of the patient, the suspected patient, and you put it on that piece of plastic. And if antibodies are present, it'll stick to the plastic as well. So that's the principle of looking for antigen.
Now, you said something about a scientific study not existing that would establish or prove that you can use an antibody test in the case of HIV testing to say that someone's infected. What would a scientific study that, let's say, validates HIV test look like? And in your opinion, does that exist anywhere? Has that ever been done?
No, I've done a thorough search of the literature, and there, I can't say that study does not exist, but my position on this has been appeared on several web pages, and I presume that the mainstream would be eager to send me that study and shut me up if it existed. And the proper study would be to compare your antibody test to the actual presence or absence of HIV. And that cannot be done. Nobody has ever isolated in pure form HIV to prove that these tests are meaningful. And I know it sounds outrageous, and it took me 5 years to convince myself that that was the case. In fact, when I was at Amgen, I actually had numerous patents that were issued in my name covering HIV diagnostic testing. So when I started to notice that that these so-called accuracies were mostly, they were centered around comparing one test to another test. So when people say that the HIV test is 99.99% accurate, or whatever it's up to today, it's really important to say at what, because it's not at diagnosing HIV. And generally those high numbers means it's 99.99% accurate. It's giving you the same answer as some other FDA-approved test.
And if that was the wrong answer, then it's really good at repeating the wrong answer.
That's correct. You've reproduced the wrong answer very accurately.
So to break down what a validation study would look like, I've always understood it to be something like this. You get 1,000 people who test HIV antibody positive, and you see from how many you can directly purify HIV, whole infectious HIV. If it's 1,000 out of 1,000, then the test truly would be 100% accurate. If it's 999 that have the virus who also test positive on the antibody test, then it's 99.9% accurate. Is that more or less how it would be?
Yeah, that's how you do it. And with germs like, STDs, chlamydia, herpes, whatever, what you do is you first run your antibody or antigen test and see it on 1,000 samples and see what your results are. And then you do what's known as culture. And that means you grow the germ up, and you grow it up in sufficient quantities and purity that you can actually directly look at it with a microscope in the case of a bacterium, with electron microscope in the case of a virus, and you see it there. And so it's a direct validation of your test. And that's how you determine how many false positives, how many true positives, et cetera, et cetera. That technology does not exist with HIV.
Can you think of any reason why?
Well, I can tell you some mainstream reasons why HIV has never been, excuse me, directly isolated. You know, according to me, I'm a chemist. Let me back up. And as a chemist, before we can claim the isolation of a new molecule or the creation of a new molecule, it's an absolute requirement that you get that molecule in a purity of excess of 99.5%. And the reason for that requirement is so that your observations with spectrographic information, infrared, spectra, et cetera, is indeed coming from a single entity rather than a combination of entities. The virologists today don't really consider that a necessary step to prove the existence of a new germ. In other words, they find phenomenon in these cultures, but they've never been able to actually purify this hypothetical HIV in sufficient quantity so that it can be directly characterized.
In recent news about the Nobel Prize being awarded to Luc Montagnier and his cohort Dr. Francois Bar, I'm not sure how to pronounce her last name, Senoussi?
I'm not sure either.
Yeah, well, okay, what's her face?
I think it's Barré-Senoussi.
Barré-Senoussi, okay. Pardon me, Francois. I wanted to ask you, I noticed that in a 1997 interview around the question, did Montagnier isolate or purify HIV, he seems to say that he didn't. That what he based the assumption that HIV was there on was the detection of indirect evidence, such as reverse transcriptase activity, or what he called, I'll give it the French pronunciation, the assemblage of factors that allowed him to imagine that if these other things associated with the retrovirus were there, then a retrovirus must be there.
Right. It's HIV exists as a matter of faith. All the evidence is indirect. Again, as a chemist, it's indirect to me because until you've purified something, how can you say it exists? But the indirect evidence is good, but it's not good enough for an organic chemist. And indeed, Luc Montagnier admitted that he never did purify the virus. Well, they jumped through the hoops of purifying the virus because this is what goes into the test kits. But if you actually purify, or I should say jump through the hoops of purifying HIV, and you take that material out and put it under an electron microscope, you don't see pure HIV. You see some small particles that are what we refer to as virus-like. And Luc Montagnier says the reason for that is because it's a very fragile virus. So after you purify it, you can't see it because it falls apart, is the notion. But then people have double purified HIV. So if you take the purified HIV and put it through the purification process again, which is a sucrose gradient, meaning these viral particles go through a sugar solution until they reach a certain density, you still see the HIV phenomena at the same place. So I guess it's kind of a paradox, is that if it fell apart on the first step, then you should not be able to purify it again, and you shouldn't see anything on the second step.
And so you're talking about things like reverse transcription, the conversion of RNA into DNA. That's what you mean by detecting.
Yeah, that's an enzyme activity that you look for, and if you see that enzyme activity, you presuppose that it's coming from HIV, even though you can't see the HIV there.
And even though if you're doubly purifying it, if it fell apart on the first purification, it can't be there for the second time, but the phenomena
right,
still
it's
happens.
still what is called banding. In other words, the viral particles have a very specific density. I think it's something like 1.16 grams per milliliter, where they travel through the solution when you centrifuge it, and they get to that density where they're happy. It's the same density as they are. And so it's really baffling as to why they travel to that same place the second time if they had died or committed suicide on the first round.
And when you're saying they, you're still referring to things that are associated, or I guess you could say biochemical activities that are associated with the virus, but the they still isn't the virus.
In my opinion, no, because how can a virus obliterate itself after you purify it? That's the explanation for why we don't see it, with an electron microscope. And yet, if you repeat the process, you once again see reverse transcriptase activity at the banding at that same place.
So if there's reverse transcriptase activity, the virus should be there making it happen.
That's the hypothesis.
But the virus isn't there, just the reverse transcriptase.
Right.
Okay, I just wanted
to... the phenomena's there, but the virus is not.
If I can just turn to a slightly different subject, one of the things that has, I think is very important is the different levels of testing standards. Like my understanding in Canada and the U.S. is that in order to be diagnosed HIV positive, you have to have 3 ELISA tests, of which 2 have to be positive, followed by at least 1 reactive Western blot. Yet in places like Africa, often the best you're going to get is 1 ELISA test, and possibly a rapid test followed by an ELISA test. Is that a reasonable summary of the state of HIV testing sequences?
Yes, it's an accurate state of the situation, and it's really tragic, I think, that there is no standardization of what constitutes a positive test result from country to country or laboratory to laboratory even. And, excuse me. And some of this, of course, is for financial reasons. Like in Africa, it's very expensive to perform a so-called confirmatory Western blot test. So researchers figured out a way to get rid of it. And since there is no gold standard, in other words, since we cannot isolate HIV and prove its existence directly, there's no way to validate these various different algorithms to see which one is working and which one is not.
In the 1980s, a researcher by the name of Burke did some analyses where he looked at the first positive ELISA and then counted the number of cases where that was repeatedly positive. In other words, the second one was positive as opposed to negative, and he found that on the second ELISA, only about half of the first positive ELISAs were repeatable with a second ELISA. So if you had, say, a situation where you were doing 3 ELISAs, I think that would mean that only 1/8 of the people who tested positive the first time, a quarter of the people who tested positive the first time would end up positive on all 3 tests. Conversely, would that not mean that if you were in a situation where you were only doing 1 test instead of 2 or 3 or 4, that you would naturally have many more people being reported positive just because you're doing fewer tests?
Oh, well, your math is good. But there's actually other reasons for this idea that you presented, that if the accuracy appears to get better and better each time you run the ELISA, therefore there's more and more false positives the first time you ran it, is not quite accurate. One of the reasons for what we call a false positive result in antibody testing is a bad test kit. In other words, say 1 in 100 test kits might have had a little fleck of dust or something that got into the manufacturing process, and that test will light up positive no matter what you put in there, like distilled water even, and it'll come up positive at the end. So that's why it's recommended to repeat testing, because the chances that you're going to get a bad test kit twice in a row is very, very slim. So when you retest, that sample is going to there's a 99% chance in this example I'm giving you that it's going to land in a good test kit. And again, I can't tell you how accurate these tests are because there is no gold standard. So that makes it very difficult to talk about, because if you have an arbitrary standard in a given country, If that arbitrary standard or combination of test results comes up positive, then you're declared infected, period. It doesn't matter why.
Now, with regard to reasons why people can come up positive, I think, at least in my opinion, I would say we know it's not saying that HIV is there. What are reasons why people might test positive on these so-called HIV tests?
Well, there's many reasons, and there's a plethora of reasons published in the literature that are called false positive or cross-reacting antibodies. That you can have antibodies to a variety of things, and they will cross-react, and it'll appear like it's an HIV antibody. And we'll never know because there is no gold standard again. And this can include vaccinations, I think genital warts, a whole plethora of conditions can cause these false positive reactions on the ELISA test. And then that's why it's recommended that you do what's called referred to as a confirmatory test to rule out the possibility that was a cross-reacting antibody. But the Western blot does not do that. It does not rule it out because the best that the manufacturers can say about a positive Western blot is that if you come up positive, let me back up. If you're positive on ELISA and you're also positive on our Western blot, you may have antibodies to HIV.
And it's true that the Western blot is also an antibody test. So if somebody has a false antibody reaction, there's a very high likelihood that that will show up on different kinds of antibody tests.
Well, yes, you'd expect that. If antibodies cross-react to a protein on one configuration, it's going to cross-react in another configuration. The extra sort of what I want to call accuracy of Western blot is that all the proteins are separated on basis of their size. So you get a whole spectrum of proteins on the Western blot, and then based on various combinations, you can say, well, this person has antibodies to 5 of the HIV proteins, and therefore it can't be a false positive.
Whereas with the ELISA, it's just they're having a reaction to the proteins as a group.
Right, just one. Could be one of them, could be more.
So when it breaks down into the Western blot, that's where we get into this area of interpretation. And I remember from a lecture that you did for the organization that I run, Alive and Well, you showed us that there's different standards of interpretation as to what proteins constitute or make up a positive reaction depending on the agency reading or giving the test. And you gave an example, if I recall correctly, that the blood banks have the lowest standard for testing positive. They have the fewest number of proteins needed to be considered HIV positive. But at the other end of the spectrum is the U.S. military, who requires reaction to the most proteins. And in each case, there's an agenda. The blood banks want to make sure that nothing dangerous or thought to be dangerous is getting in the blood supply, whereas the U.S. military does not want to turn away new recruits. Is that more or less correct to what you explained to us?
Well, yes, it is. The blood banks, the definition has changed over time, too, because blood banks are required, of course, to use FDA-approved products. Some labs use homemade products. I'll refer to the number of bands is what we refer to as stringent. How stringent do you want to be before you tell this person that they're positive for antibodies to HIV, and therefore presumed to be infected with HIV? And clearly, the more bands that you require, the fewer people are going to turn up positive. So depending on your needs, you can tailor your test to your population to get the result you want. In particular, in Africa, where only a single antibody screening test, such as an ELISA or a rapid test, is used, you see very high prevalence of HIV. In my opinion, most likely, the majority of those are false positives.
When you say stringency, too, that brings up another question with regard to interpretation. I seem to recall you mentioning that when these tests were being developed, that in the beginning there were too many positives found among healthy blood donors. And there was great concern about the implications for that. And it was almost, I guess, decided that the stringency level had to be brought down if this test were going to have a practical application in the general population, because you couldn't have a bunch of healthy people testing positive.
That's right.
Could you elaborate on that a little bit more?
Yeah, it's sort of a strange story. When Abbott Laboratories released their test, and after approval by the FDA, there was, before that happened, actually there was a dialogue amongst people in the blood banks, those in charge of public health, such as the CDC, researchers, etc. And it's like, what do we do, if a healthy blood donor tests positive? Can't we just, the blood banks said, well, we'll just throw that unit of blood away and call it a loss. But the Centers for Disease Control said, no, anybody that donates blood, after the release of this test, I think it was March or April 1985, that they would have to be told about their positive result, and that they should go work it out with their doctor. And the reason, of course, that the CDC wanted to tell everybody that had a positive test result was to prevent further spread of infection. In other words, we have to, even if there's a chance that these people are infected, we have to let them know so that they can go to their doctor and they can stop spreading the virus in the public. Unfortunately, doctors had no tools at that time, nor do they today, to confirm an infection with HIV. So these people were left in a state of constant anxiety, and that I think the literature would suggest that there are about 50,000 blood donors within the first 2 years of the release of this test were told that they might be infected with HIV, and it was a disaster. I mean. And many of those people would go home and probably tell their sexual contacts that I might be infected with HIV. Those persons would go on and tell their own sexual contacts the same. So this was a disaster at the social level of people being told that they might die and that they're healthy blood donors. So that's why the the Western blot was the true motivation for why the Western blot was developed. It was in order to tell those blood donors you're not infected, because if you're holding out HIV to be deadly, first of all, you can't have 50,000 healthy blood donors out there. They should be sickly. So that's when the FDA put a very stringent criteria on calling the Western blot positive. A total of, I think 4 bands or different combinations of bands, and finally those people that were living a life of anxiety and terror could be told that they're not infected.
Or that they were.
Or that they were, in very rare cases, yes.
Mm-hmm. But even then it wouldn't necessarily be correct, because we still don't have anything available to this day to confirm that idea.
Yeah, and based on the stringent definition of Western blot that was approved in 1987, probably 99% of those blood donors, or even more, could finally be told that they were not infected.
And does this not also mean that in a place like Africa, where the Western blot is not used, that even if there were some true positives, that the majority of Africans are probably false positives because they're not getting the same stringency of testing?
Well, yes. There's a direct correlation between the stringency and the number of false positives that are going to come up. And, of course, in Africa, most people don't even know whether they're antibody positive for HIV or not. These are surveys that are conducted on pregnant women that come to public pregnancy clinics, and their blood is drawn for syphilis testing, and the leftover blood is used for HIV diagnostic testing, and it's all anonymous. So it's very profitable business, and the more people you can perceive to be infected, the more money's going to come in from donor organizations. So in a business sense, it makes you don't want to be very stringent.
Right. Going on to the viral load test, there's since the I guess the mid 1990s, even the viral load test has risen to prominence. This is a genetic test and sort of has the feeling that it's much more accurate. Well, because it's called viral load. Can you describe what the viral load test is? Specifically, does it measure the number of virus particles? And you had some experience developing such a test, so maybe you could talk about that as well.
Yeah, in fact, that was my field of expertise, was using genetic information to search for genetic information at the molecular level. A viral load test, like an antigen test, looks for a fragment of the germ. In this case, that fragment is the genetic material that's carried with the germ. And the idea is if you see that genetic information or if you see that antigen, there's a higher probability that the entire germ is still there. But if you read the manufacturer's package insert for the HIV viral load test that's on the market, or tests, plural, that are on the market, all of them say, do not use this test for diagnosing infection with HIV. I mean, it's right up front. And the reason for that is there are false positives at that level as well. And apparently they're so prevalent that depending on the study, the false positives that come out of HIV viral load testing are anywhere from 1 to 10%. So all of these tests say do not use this for diagnosing infection. The reason they were approved was for managing patients that are being treated. In other words, you want to observe the viral load, and if it goes up, you presume the virus has mutated, and you change medications. So that was, it's really been abused, and even mainstream researchers have emphasized in the literature that the HIV viral load test was never validated nor intended for use in diagnosing infection with HIV.
So in other words, there's never been a widespread survey of the healthy population to see how many of them would be positive on a viral load test when quite clearly they don't have the virus in their body.
Right. At best, as I said, at least 1% of the population that is not infected would come up positive. And since we have about 300 million people in this country now, that would be about 3 million people would be told they're infected when indeed they're not, as compared to a estimated 1 million persons that are infected.
And if you're developing a genetic test for an RNA virus, would you not want to purify the virus to make sure that the RNA is really coming from the virus? And was that done when they developed viral load tests?
I would insist on it, of course, because I'm a chemist and that's the rules we play by. And that has never been done. The genetic information, like the reverse transcriptase activity, et cetera, is found in what's called HIV cultures, but we do not know where it came from. I mean, we don't know if it's from the virus. The human genome, these cultures are in human cells, and the human genome contains 1 to 2% retroviral sequences in what's called the nonsense regions of our chromosomes. Excuse me again. So this could have well come from the human cells in the culture as opposed to a virus.
With all of this discussion, as somebody who's been labeled HIV positive, I can't help but to wonder about the terminology around all of this. HIV test, HIV positive, HIV viral load. There's just a gap in the logic and the science and even in the ethics of this. If there is no HIV isolate, if there is no test that finds HIV, if there is no validation of tests not looking for HIV that finds something else by the finding of HIV, how can we even use these terms to describe anything? What is a false positive? What is a true positive when we aren't testing for the virus itself. We're testing for things associated with the virus, but none of the tests for the things have been validated by the ability to find the virus in people who test positive for the things. You know what I mean? It seems like a cruel and bizarre system that at some point prior to this moment would have become obvious to somebody somewhere along the line, and they'd say, well, hey, we need to resolve this matter. We're telling people all over the world in all kinds of circumstances that they're carrying, that they're infected with a deadly virus, yet we haven't found this virus in anybody. We haven't isolated this virus from cell culture. What are we doing? Why don't we go back and create the original experiments necessary to be able to tell people this with scientific accuracy and with, the humanity in mind, the humanity of this situation?
Well, Christine, these issues get outside of my area of expertise a little bit. You're talking more about social political issues, and as well as the political economy of this germ. But I really think that the first step is just start telling patients the truth. In other words, informed consent. I'm not anti-pharmaceutical. I'm pro-informed consent. And the truth is that the manufacturers of these tests make no such claim that they can be used to diagnose infection with HIV. And the new term really has become AID, A-I-D. And all the manufacturers say that my test kit is intended to aid in the diagnosis of HIV antibodies, for example. A thermometer is an aid to be used in the diagnosis of HIV/AIDS. And the package inserts also clearly state that the significance of a positive result in a healthy person is not known. The FDA had that same announcement in their news release in 1987 when the first Western blot was approved. And nobody pays attention to that. Nobody knows what the meaning of these tests are in healthy persons. And the vast majority of people that are told that they're infected with HIV are healthy. In other words, they may have depressed, by the new CDC definition of what AIDS is, using the low T-cell count. Those persons are still healthy. So it's baffling. And all these things that we hear, like HIV test, HIV positive, viral load, that you mentioned, Christine, that jargon comes from recommendations from our public health institutions. These recommendations are not necessarily based on scientific evidence, and that's why you'll see a little footnote on the front of all of them is that the recommendations contained in here may not fit the legal definition that the FDA has to abide by. So that's where you get these terminologies, and why does that happen? It's because everybody is conflicted. Everybody now that sits on panels to approve drugs, to approve diagnostic products, in one way or another is getting pharmaceutical money. Not everyone. I shouldn't generalize that broadly. And as a group, if you see antibodies equaling infection, and that means billions of dollars flowing into the HIV/AIDS incorporated pipeline, it's easy to see it that way.
I wrote an article once called Manufacturing Certainty, which was an obvious reference to Noam Chomsky's book, Manufacturing Consent. But the observation I made was that modern medicine loves things that are certain. This test is 99.999% accurate. You can believe this. This drug will work. It would be very much more difficult to do medicine if it was things like, well, there's a 75% chance you're infected with a deadly virus and a 25% chance there's absolutely nothing wrong with you at all. I don't think you'd get so many people taking drugs if they admitted there was some uncertainty, and if they admitted that there were fundamental unknowns, such as whether HIV has ever been purified and whether the viral load is really looking for HIV or something else. I don't think you'd get anybody to take drugs or assume that their life was over.
For a field and an endeavor that loves certainty, it seems to me there's a lot of uncertainty around what everybody's decided to agree that there's certainty about.
Yeah, and I hope that having Rodney on this show will get our listeners to understand some of those uncertainties a little bit better, because the impact of these tests psychologically, when somebody says with certainty you're HIV positive, is very powerful. And I think when they're kind of deconstructed, like you've helped us do, Rodney, I think that helps people understand that they may want to look at that result with a great deal more skepticism.
Yeah, I agree. And as I said, if people were just told the truth about the limitations of these tests, I think perhaps these tests might even be of some value. In other words, if you get a positive ELISA and a positive Western blot, and your physician came to you and said, well, you know what? According to the manufacturer, this says that you may have antibodies to HIV. And according to the CDC, persons with antibodies are presumed to be infected with the virus. At least you wouldn't terrify the person to death. And maybe the doctor could say, perhaps you should come back in 6 months if you have any symptoms, and we'll address this issue at a later time. But that's not clearly what happens.
As somebody, again, who's had that conversation with the doctor that involved much more certainty, I still don't think that gets to the point of this. Because if you're giving people a test that can't tell if they have what you're suggesting they may have, all you're doing is creating that anxiety that you spoke about in the early days, Rodney, where blood donors were almost cruelly told you may have something that could possibly kill you, that you could possibly pass on to someone else and kill them. And we're not sure. It's not like that's really helpful.
Well, I agree. And in my opinion, these tests should be thrown in the trash. I mean, there's absolutely no reason for them at the individual level. And the reason that these tests are not going to go away, Christine, is because of the battle between individual health and public health. And as long as it's perceived that there's an infectious agent that can spread into the general public, our public health officials need to have that that antibody test. And in other words, if you told an individual the things I mentioned earlier right up front, is that I can do this test, and if you come up positive, you may or may not have antibodies to HIV. You would be presumed to be infected according to the CDC. They wouldn't take it. I mean, I wouldn't take it. I wanted to say, well, if you don't have a test that can tell me with any degree of certainty whether I'm infected or not, why would I take it?
And I think also if you tell people the social consequences, if you take this test and test positive and have unprotected sex with somebody without telling them you're HIV positive, you could go to jail. And if you're a woman and you have a baby, we may take your baby away. I think that would give a lot of people second thoughts as well.
Well, those are very serious side consequences as a sort of a corollary to this whole practice.
Right.
And and if there was a test on the market that said that this test can detect HIV, FDA approved, with even 80% certainty, I'd say use it. But you're right, the criminalization of HIV/AIDS is becoming a serious problem. On the other hand, in Africa, where governments are trying to employ this same strategy of criminalization, they see a drop in people coming forward to be tested. And in many countries, there's no treatment available yet anyway, so why would they go get tested and later put themselves at risk to go to prison for passing on or appearing to pass on a positive antibody result?
Yeah, that's good questions. I can't thank you enough for being on our show today, Rodney. It's been great to talk to a true expert on this issue.
Well, I enjoyed the conversation.
Thank you very much, Rodney. Certainly what you've brought up will lead to many questions on the part of our listeners. And I think that in a situation like the one we have, the best we can do is ask these questions and demand answers, because the answers, it seems, aren't there in the scientific literature.
You're right. And I actually did publish a article in the electronic version of the British Medical Journal demanding that the research community develop an HIV test. And I really think that all these people that have been living a life of fear and terror deserve such a test. But until such time that we actually have an HIV test we'll have to employ other methods to try to get information to people.
And thank you.
Thank you.
Thank you. Well, that was great listening to such a world expert on HIV testing and somebody who's obviously come a long way from his initial beliefs in the HIV/AIDS paradigm.
I'm still struck with the whole surreal nature of this thing called an HIV test that isn't an HIV test. I remember in our art history classes, we looked at those paintings by Magritte, the French surrealist, including the one where it's a painting of a pipe, and underneath it says, "This is not a pipe." And here you have an antibody test that underneath that title says, "There is no standard for diagnosing the presence or absence of HIV antibody in human blood." It's so surreal.
I remember listening to a book tape of Death on the Nile, a famous Agatha Christie book, and there's a scene in there where this young heiress is just about to sign her fortune away to the scam artist, and somebody comes up and interrupts this thing that's going on and tells her, "Always read what you're about to sign." But how many people read the HIV testing literature, which is essentially their death warrant if they believe it? How many people are even given those labels? I don't even think most doctors have those labels.
Yeah, it's quite a situation. Well, David, in our next show, which will be podcast number 7, we have a very interesting guest, a gentleman from out here in California, West Hollywood, California, who came down with symptoms that would very readily be called AIDS, especially because he's a gay man. Sudden, precipitous weight loss, then neurological disorders, numbness, and eventually paralysis, and just general immune breakdown. But he was not inclined to take an HIV test and not inclined to accept an easy label. He found his own solution working with alternative health practitioners and went from someone who was so bad off he could barely speak or move, and he's fine. And he has a very interesting story to tell, and he'll be with us in the next podcast, number 7.
I can't wait to talk to him. That sounds extremely interesting, and hopefully we'll get other people who've experienced some of the same things thinking about that. I'd just like to say thanks to all of our listeners. I hope you've enjoyed this show, and more than that, I hope you found it useful, thought-provoking, and challenging. If you have, tell your friends about it, and let's see if we can get to 5,000 downloads by our next podcast.
That would be wonderful. Well, thank you, David, and goodbye, everyone. Until the next time.
Goodbye.